Welcome to the Warangal Urban digital classes. In the previous classes, you have learnt about numbers, fundamental operations on numbers, that is additions, subtractions, multiplications and divisions on number system, and more other operations. Now, today we shall explore more about division algorithm, that is Euclid's division lemma. Let us see some series of activities for remainders. Divide the following 7 pencils between 2 persons equally. Here we have 7 pencils, 2 persons. First we give them each one. There is 5 pencils remains. Next to give them each one. There is 3 pencils remains. Again we give them each one. 1 pencil remain. This 1 pencil cannot divide 2 persons equally. Therefore each one gets 3 pencils and 1 pencil remain. That is 7 is equal to 3 plus 3 plus 1. 7 is equal to 2 times 3 plus 1. Here 1 is the remainder. Now general division, 7 divided by 2. 2 3 are 6. 7 minus 6, 1. 1 is the remainder. We can also write this as 7 is equal to 2 times 3 plus 1. In both cases 1 is the remainder. 7 is equal to 2 times 3 plus 1. Divide the following 8 mangoes between 2 persons equally. Here we have 8 mangoes, 2 persons. First we give them each one. There are 6 mangoes. Next we give them each one. There are 4 mangoes. Again we give them each one. There are 2 mangoes remain. Give them again each one. There is 0 mangoes. Therefore, each one gets 4 mangoes and 0 mangoes remain. That is 8 is equal to 4 plus 4 plus 0. 8 is equal to 2 times 4 plus 0. General division, divide 8 by 2. 2 4 are 8. 8 minus 8, 0. 0 is the remainder. We can also write this as 2 times 4 plus 0. In both cases 8 is equal to 2 times 4 plus 0, where 0 is the remainder. Divide the following 9 bananas between 2 persons equally. Here we have 9 bananas, 2 persons. First we give them each one. There are 7 bananas remains. Next we give them each one. There are 5 bananas remains. Again give them each one. There are 3 bananas. Next we give them each one. There is 1 banana remain. Therefore each one gets 4 bananas and 1 banana remain. That is 9 is equal to 4 plus 4 plus 1. 9 is equal to 2 times 4 plus 1. General division of 9 by 2. 2 4 are 8. 9 minus 8, 1. 1 is the remainder. This we can also write as 9 is equal to 2 times 4 plus 1. In both cases 9 is equal to 2 times 4 plus 1, where 1 is the remainder. Divide the following 10 balls between 2 persons equally. Here we have 10 balls, 2 persons. First we give them each one. There are 8 balls. Next we give them each one. There are 6 balls. Next each one. There are 4 balls. Next give them each one. There are 2 balls. Again we give them each one. There is 0 balls remains. Therefore, each one gets 5 balls and 0 balls remain. That is 10 is equal to 5 plus 5 plus 0. Therefore, 10 is equal to 2 times 5 plus 0. 10 divided by 2. 2 5 ja 10. 10 minus 10, 0. This we can also write as 10 is equal to 2 times 5 plus 0. In both cases, 10 is equal to 2 times 5 plus 0, where 0 is the remainder. Divide the following 10 oranges among 3 persons equally. Here we have 10 oranges, 3 persons. First we give them each one. There are 7 oranges. Next we give them each one. There are 4 oranges. Again give them each one. There is 1 orange remains. It is not possible to distribute 3 persons equally. Therefore, each one gets 3 oranges and 1 orange remain. That is 10 is equal to 3 plus 3 plus 3 plus 1. Therefore, 10 is equal to 3 times 3 plus 1. General division of 10 by 3. 3 3 ja 9. 10 minus 9, 1. This can also write as 10 is equal to 3 times 3 plus 1. In both cases, 10 is equals to 3 times 3 plus 1, where 1 is the remainder. Divide the following 9 flower plots among 3 persons equally. Here we have 9 flower pots, 3 persons. First we give them each one. There are 6 power plots. Again we give them each one. There are 3 power plots remain. Next we give them each one. There is 0 power plots remain. Therefore, each one gets 3 power pots and 0 pots remain. That is 9 is equal to 3 plus 3 plus 3 plus 0. That is 9 is equals to 3 times 3 plus 0. General division 9 divided by 3. So 3 3 ja 9. 9 minus 9, 0 remainder. This can also write as 9 is equal to 3 times 3 plus 0. In both cases, 9 is equal to 3 times 3 plus 0, where 0 is the remainder. Divide the following 7 pomegranates among 3 persons equally. Here we have 11 pomegranates, 3 persons. First we give them each one. There are 8 pomegranates remain. Next we give them each one. There are 5 pomegranates remain. Next we give them each one. There are 2 pomegranates remains. These 2 are not possible to distribute 3 persons equally. Therefore, each one gets 3 pomegranates and 2 pomegranates remains. That is 11 is equal to 3 plus 3 plus 3 plus 2. Therefore, 11 is equal to 3 times 3 plus 2. General division of 11 by 3. 3 3 ja 9. 11 minus 9, 2. We can also write this as 11 equals to 3 times 3 plus 2. In both cases, 11 is equal to 3 times 3 plus 2, where 2 is the remainder. Divide the following 7 pens among 3 persons equally. Here we have 7 pens, 3 persons. First we give them each one. There are 4 pens remains. Next we give them each one. there is one pen remain. It is not possible to distribute 3% equally. Therefore, each one gets 2 pens and 1 pen remain. That is 7 is equal to 2 plus 2 plus 2 plus 1. Therefore, 7 is equal to 3 times 2 plus 1. General division of 7 by 3. 3 2 ja 6. 7 minus 6 1. This can also write as 7 is equal to 3 times 2 plus 1. In both cases 7 is equal to 3 times 2 plus 1, where 1 is the remainder. Divide the following 6 roses among 3 power pots equally. That is, we arrange the 6 powers into the flower pots. Here we have 6 roses. We can arrange in equally into 3 power plots. First we arrange each one in each power plot. There are 3 roses remains. Again we arrange each one. There are 0 roses remains. Therefore, each one gets 2 roses and 0 roses remains. That is 6 is equal to 2 plus 2 plus 2 plus 0. Therefore, 6 is equal to 3 times 2 plus 0. General division of 6 by 3. 3 2 ja 6. 6 minus 6 0. This can also write as 6 is equal to 3 times 2 plus 0. In both cases 6 is equal to 3 times 2 plus 0, where 0 is the remainder. Divide the following 5 pencils among 3 persons equally. Here we have 5 pencils, 3 persons. First we give them each one. There are 2 pencils remains. It is impossible to distribute these 2 pencils 3 persons. Therefore, each one gets 1 pencil and 2 pencils remains. That is 5 is equal to 1 plus 1 plus 1 plus 2. Therefore, 5 is equal to 3 times 1 plus 2. General division of 5 by 3. 3 1 ja 3, 5 minus 3 2. This can also write as 5 is equals to 3 times 1 plus 2. In both cases 5 is equals to 3 times 1 plus 2, where 2 is the remainder. Do the following divisions: 23 by 4, 23 by 4, 4 5 ja 20, 23 minus 20, 3 remainder. This can also write as 23 is equal to 4 times 5 plus 3. 25 by 4, 25 by 4, 4 6 are 24, 25 minus 24 is equals to 1 remainder. This can also write as 25 is equals to 4 times 6 plus 1. 24 by 4, 4 6 are 24, 24 minus 24 0, 24 is equals to 4 times 6 plus 0. 26 divided by 4, so 4 6 are 24, 26 minus 24 2, 26 is equals to 4 times 6 plus 2. In these 4 examples, remainders are either 3 or 1 or 0 or 2. Similarly, we do the some more divisions. 14 by 4, 4 3 are 12, 14 minus 12, 2 remainder. 14 is equals to 4 times 3 plus 2. 20 divided by 4, 4 5 are 20, 20 minus 20 is 0, 20 is equals to 4 times 5 plus 0. 27 divided by 4, 4 6 are 24, so 27 minus 24, 3 is the remainder. 27 is equals to 4 times 6 plus 3. Next example, 29 by 4, so 4 7 are 28, 29 minus 28, 1 is the remainder. This can also write as 29 is equals to 4 times 7 plus 1, where 1 is the remainder. In these 4 examples, we noticed that the remainders are either 2 or 0 or 3 or 1. When a number is divided by 2, the remainders are division with 2, 7 by 2, 2 3 is 6, 7 minus 6, 1 remainder. 8 divided by 2, 2 4 is 8, 8 minus 8, 0. 9 divided by 2, 2 4 is 8, 9 minus 8, 1. 10 divided by 2, 2 5 is 10, 10 minus 10, 0. Here in the 4 examples, we noticed that when divided by any number by 2, we get remainders either 0 or 1. So when a number is divided by 2, the remainders are either 0 or 1. We note this as 0 less than or equal to remainder less than 2. Similarly, when a number is divided by 3, the remainders are 10 by 3, 3 3 is 9, 10 minus 9, 1, 1 is the remainder. 9 by 3, 3 3 is 9, 9 minus 9, 0 is the remainder. 8 by 3, 3 2 is 6, 8 minus 6, 2 is the remainder. 6 by 3, 3 2 is 6, 6 minus 6, 0, 0 is the remainder. 7 by 3, 3 2 is 6, 7 minus 6, 1 is the remainder. 5 by 3, 3 1 is 3, 5 minus 3, 2 is the remainder. So when a number is divided by 3, the remainders are either 0 or 1 or 2 from the above examples. We note this as 0 less than or equals to remainder less than 3. When a number is divided by 4, the remainders are 23 by 4, 4 5 are 20, 23 minus 20, 3 is the remainder. 25 by 4, 4 6 are 24, 25 minus 24, 1 is the remainder. 24 by 4, 4 6 are 24, 24 minus 24, 0 is the remainder. 26 by 4, 4 6 are 24, 26 minus 24, 2 is the remainder. 14 by 4, 4 3 are 12, 14 minus 12, 2 is the remainder. 20 by 4, 4 5 are 20, 20 minus 20, 0. 27 by 4, 4 6 are 24, 27 minus 24, 3 is the remainder. 29 by 4, 4 7 are 28, 29 minus 28, 1 is the remainder. By observation, when a number is divided by 4, the remainders are either 0 or 1 or 2 or 3. We note this as 0 less than or is equals to remainder less than 4. Relation between divisor and remainder, dividend, divisor, remainder, or relation between divisor and remainder. Dividend be any positive integer, If we divide any positive integer by 2, then we get remainders either 0 or 1. If we divide any positive integer by 3, then we get the remainder either 0 or 1 or 2. If we divide any positive integer by 4, then we get the remainder either 0 or 1 or 2 or 3. If we divide any positive integer by 5, then we get the remainders either 0 or 1 or 2 or 3 or 4. We divide any positive integer by 6, then we get the remainders either 0 or 1 or 2 or 3 or 4 or 5. By inspection of all these examples, we noticed that highest remainder is 1 less than the respective divisor, and other remainders are less than the divisor. Now here we can establish a relation between divisor and remainder. If 6 is the divisor, then the relation between 6 and the remainders is 0 less than or is equals to or less than 6. If 5 is the divisor, then the relation between 5 and remainders is 0 less than or equals to or less than 5. If 4 is the divisor, then the relation between 4 and the remainders is 0 less than or equals to or less than 4. If 3 is the divisor, then the relation between 3 and the remainders is 0 less than or equals to or less than 3. If 2 is the divisor, then the relation between 2 and the remainders is 0 less than or equals to or less than 2. We continue this process. Any positive integer as a dividend, any positive integer as a divisor, we can also establish a relation. Let divisor be b and remainder be r, then the relation between b and r is 0 less than or equals to or less than b from above pattern. Relation between dividend, divisor, quotient and remainder. Dividend, divisor, quotient, remainder are relation between dividend, divisor, quotient and remainder. If 7 is the dividend, if we divide by 2, quotient is 3, remainder is 1. Then the relation between 7, 2, 3 and 1 is 7 is equal to 2 times 3 plus 1. 8 is the dividend, 2 is the divisor, then quotient is 4, remainder 0. Then the relation between these 8, 2, 4 and 0 is 8 is equals to 2 times 4 plus 0. 14 divided by 3, quotient 4, remainder 2. Relation between 14, 3, 4 and 2 is 14 is equal to 3 times 4 plus 2. 9 divisor 3. If divide by 9 by 3, we get the quotient 3, remainder 0. Relation between 9, 3, 3 and 0 is 9 is equal to 3 times 3 plus 0. Dividend is 7, divisor is 3, then we get the quotient 2, remainder 1. The relation between these numbers is 7 is equal to 3 times 2 plus 1. 23 is the dividend, 4 is the divisor. When we divide 23 by 4, the quotient is 5, remainder is 3. Then 23 is equals to 4 5 ja 20 plus 3. 24 is the dividend, 4 is the divisor. We divide 24 by 4, we get the quotient 6, remainder 0. relation between these numbers, 24 is equals to 4 times 6 plus 0. 19 is the dividend, 5 is the divisor. If we divide 19 by 5, we get quotient 3, remainder 4. Relation between these numbers is 19 is equals to 5 times 3 plus 4. We continue this process for any positive integer as a dividend, any positive integer as a divisor, we get some quotient and remainder. By observation of these all, we establish a relation between dividend, divisor, quotient and remainder. Let dividend be x, divisor be d, quotient be y, remainder be r. Then the relation between x, d, y and r is x is equals to d times y plus r. From this above table, we notice that in the process of writing above equations, unknowingly, we have used division algorithm. Let us conclude this. Given positive integers a and b, there exists a unique pair of positive integers q and r such that a is equals to bq plus r, where 0 less than or is equals to r less than b. This is called as division algorithm. This result was first recorded in book 7 of Euclid's element as Euclid's algorithm. Children, do this. Find q and r for the following pairs of positive integers a and b, satisfying a is equals to bq plus r, where a is equal to 13, b is equals to 3. Another problem, a is equal to 80, b is equals to 8. Solution. For first problem, given a is equal to 13 and b is equals to 3, apply division algorithm with a is equal to 13 and b is equal to 3. Here we divide 13 by 3, we get 13 is equals to 3 times 4 plus 1. Compare this with a is equals to bq plus r, we get q is equals to 4 and r is equals to 1. For the problem number 2, given a is equal to 80 and b is equal to 8, apply division algorithm with a is equal to 80 and b is equal to 8. Divide 80 by 8, we get 80 is equal to 8 times 10 plus 0. We compare with this with a is equal to bq plus r, then we get q is equal to 10 and r is equals to 0. Hence the problem solved. One more problem. Use division algorithm, show that any positive integer is of the form 3 cube or 3 cube plus 1 or 3 cube plus 2 for integer q. Solution. Let a be any positive integer and b is equals to 3. Why we chosen b is equals to 3? Children, let us see in the problem required to prove any positive integer in the form of either 3q or 3q plus 1 or 3q plus 2. In that, the coefficient of q is 3. Therefore, we chosen b is equals to 3. Apply division algorithm a and b is equals to 3. A is equals to 3q plus r, where 0 less than or equal to r less than 3 and q is some integer. Here 0 less than or equal to r less than 3, that is r is equal to either 0 or 1 or 2. If r is equal to 0, then a is equal to 3q plus 0, that is a equal to 3q. If r is equals to 1, then a is equal to 3q plus 1. If r is equals to 2, then a is equal to 3q plus 2, where q is some integer. Here we notice that a is equal to 3q or 3q plus 1 or 3q plus 2, where q is some integer by division algorithm. Hence the problem proved. Children, try this. Find q and r for the following pairs of positive integers a and b satisfying a is equal to bq plus r. A is equal to 125, b is equal to 5. A is equal to 132, b is equal to 11. Discuss with your friends and your teacher. Solve these problems. What we learned today? Today we learned about division algorithm, that is Euclid's division algorithm or Euclid division lemma. Children, you all have understood the concept of division algorithm, that is Euclid's division lemma, and apply the same in the attempting the problems of division algorithm. Enjoy learning. We meet again in the next class with another topic.